In order for a drilling rig to run smoothly, a lot of things have to be operating properly. Everything here seems to be running all right. Except for one minor little detail.
Oh! Son of a... Come on, work! Oh! Oh! Oh!
Hey, Sam!
Yeah, over here!
Hey, Sam, you got that water maker working yet? I need some water to cook with.
Look, man, I'm doing everything I can.
Yeah, sure looks like it.
Yeah, well, I am.
Hey, Sam, where's the water? I've got to mix more mud. What seems to be the problem here?
I don't know, man. I've been keeping records. Everything is going along just fine, but then all of a sudden, everything quit.
Well, I don't care what's wrong. Just get it going. We're going to have serious problems down hole. I need to mix lost mud right now.
Any idiot knows you shouldn't be using this water for mud anyway.
What seems to be the problem this time, Sam?
Oh, I don't know. I've been keeping records just like you said. Here.
Let's see here.
Well, look at this. Today the bottom just fell out. What happened?
I don't really know, Sam. Why don't you go ahead and start it, and we'll check it out from there.
Well, okay now, let's see. First, I push this button right here, right?
Come on, Sam, you know that's not right. First, you should check the oil level in the compressor.
Oh, yeah? Where's that?
Look, let me go over the entire startup procedure, and we'll look for a problem from there, okay?
Okay.
There are a couple of things that you ought to check before turning anything on, and the lube oil level is only one of them. Lube oil is measured here on this sight glass. It should be about a half an inch from the bottom. If it isn't, add the recommended 10 or 20 weight non-detergent oil. The viscosity of the oil depends on the normal oil operating temperature. For up to 130 degrees, use SAE 10. For above 130 degrees, use SAE 20. Now, don't use any of that expensive synthetic stuff. Regular oil is best for this particular system. And another thing that should be checked first is the water level in the boiler. The immersion heaters won't operate if you're short on water, and you should use only fresh, pure water. Most installations have a direct line into the boiler from the water storage tanks, but you'll usually find there's already plenty of fresh water there because during normal operation, the AquaChem automatically refills itself as it operates, but it should be checked anyway. For startup, all of the valves should be closed except for the steam chest vent condenser. It should be fully open. Now, start the recirculation pump and open the cooling water supply valve for the recirc pump seal a quarter of a turn. Open the feed water control valve and fill the sump to within 2 inches of the top of the sight glass. Then shut it off. The boiler water needs to be heated to about 215 degrees. So turn all 3 heaters on and keep a watch on the temperature gauge. Make sure that your feed water and blowdown strainers aren't bypassed. Then open the compressor drain valve located on the left-hand side of the compressor motor. On the S600, this is automatic. Now set the distillate valve to divert the distillate to waste. All you have to do now is wait until the recirculating temperature reaches 214 degrees Fahrenheit. Be patient. It might take an hour or more to heat up, but it has to be at least 214 degrees, or the unit won't operate. A quick glance at the maintenance schedule will tell you if any maintenance is due. You should have been keeping up with this all along, in addition to your daily operational data sheets. It's real easy to keep up with. Just take the last 3 black numbers off of the hours meter. If it reads 125, you know that you need to lubricate the distillate and recirc pumps. When the meter reads 250, not only do you grease the pumps, but you also adjust your belt tension and alignment. First, the recirc and distillate belts. Then a quick check of the centrifugal compressor. Use a straight edge to check alignment. Hold the edge flush with the motor sheave and move it into the compressor sheave. The straight edge should just touch the face of the compressor sheave. The other side should be the same. If it's not perfect, it'll ruin your belts real fast, so an adjustment will have to be made. If the sheave is aligned properly, but just forward or backward of where it should be, loosen the set screw on the motor sheave and tap it into perfect alignment. Then lock it down good. Don't move the compressor sheave. We'll get into more detail on this a little later. Finally, check your belt tension to be sure that it's correct. The gauge for doing this is supplied with each Aquachem, or additional gauges can be ordered from Aquachem. It's part number 943-7594. Proper belt tension is really more important than most people realize. 50% of all the compressor damage that we've seen is caused by too tight a belt tension. It fits on the belt like this. The pivot point should be halfway between the two sheaves. Make sure that this indicator hand is all the way up. Hold a sheet of paper between the belt and this lower arm. Press down on the lever until the lower arm is just touching the paper. Then let go of the lever and take the gauge off. Now look closely at the indicator hand. You'll notice that there are 3 scales to read from. Always read off of the center scale, the one labeled 7M4L, and read from this part of the hand. The different sized water makers use different tensions, so refer to the manual for the proper tension measurements. If tension is too low or too high, adjust it by loosening or tightening the 2 left-hand motor bolts front and back. Make sure that you loosen or tighten them equally. And be sure to check the belts for cracks and signs of wear every day. If you have to replace them, check the tension again after about 15 to 20 minutes of operation, once they've had a chance to seat properly, and replace them only with matched sets of belts. On our newer water makers, a type of multi-section power band has been provided. This band is an improvement over the old separate belt system. Any new belts you purchase will be this type and will fit your existing pulleys. Now, check these items off on your schedule sheet as you complete them. When the hour meter reads 375 hours, all you need to do is lubricate the pumps again. But at 500 hours, you'll need to do all of this, plus check the torque on all of the bolts, except for the ones on the volute and end covers of the compressor. Again, at 625 hours, a pump lubrication is called for. And at 750 hours, you'll need to check these items, plus the safety switch operation, just to make sure that they're working right. Have the electrician do this. You'll find a detailed procedure in your operations manual. Continue with this same pattern and add an oil filter change at 1,000 hours. The filter is fairly easy to change. Just get a bucket to catch the oil. Then pull the filter cover off by loosening this bolt. Remove the old filter and dump the old oil out. It might have some sediment trapped in it. Then insert the new filter and reassemble it. Tighten the hex nut first, preferably with the right-sized wrench instead of pliers. Then use a screwdriver to tighten the screw. Turn the lube oil pump on and let the pressure rise. Remove the breather cap and add oil. Keep adding until there's about a ½ inch showing in the view glass. Pump lubrication needs to be checked every 125 hours. Belt tension and alignment and belt inspections at 250-hour intervals. Bolt torque checks at 500-hour intervals. And safety switch checks at 750-hour intervals. At 2,000 hours, you'll need to change the oil filter and oil in the centrifugal compressor oil pump. First, remove the discharge hose at the head tank. Turn the pump on so that the old oil will be pumped out of the system. Then turn the pump off and replace the hose. change the filter, and refill the system like we did earlier. Also at 2,000 hours, you'll need to change the oil in the chemical treatment pump. Check your maintenance manual for this procedure. Next, a check of the centrifugal compressor axial and radial play will need to be made. You'll need a dial indicator to check this with. There shouldn't be more than 4 to 6 thousandths axial play.
10,000, sir.
This one will have to be shimmed. And there shouldn't be more than 10 to 12 thousandths radial play when the compressor is below 110 degrees Fahrenheit. If there is, the compressor has a problem, and you'd better fix it before any serious damage is done. Check your maintenance manual for procedures. And finally, at 2,000 hours, you'll need to have the electrician check the contactors and starters inside the control panel to make sure that they're clean and operating properly. Whenever scheduled maintenance is called for, perform it before firing the machine up. In most cases, it takes less time to perform the maintenance than it takes the heaters to warm the unit up, so it could be done while you're waiting. Okay, back to the startup procedures. Once the compressor suction pressure reaches 0.5 to 1.0 psig, you're about ready to start the unit up. You'll get steam out of the steam chest vent valve, and the recirc thermometer will be about 214 to 215 degrees Fahrenheit. Don't wait too long or all of the water will boil out of the boiler. 2 minutes before starting the centrifugal compressor, turn the lube oil pump on. This will get plenty of oil flowing through the compressor and get all of the air out of the bearing cavity. Watch the oil pressure. Make sure that it's between 15 and 20 pounds per square inch before starting the centrifugal compressor. It might be necessary to readjust the oil bypass valve to get it within this range. Okay, after 2 minutes, start the compressor and open the distillate shutoff valve fully. Now, slowly open the feed water control valve to flow at about 1/3 of the plant's distillate capacity. On this S300, that would be about 3.5 gallons per minute. If too much cold water is introduced into the system too quickly, it'll cause the unit to cool down too rapidly and shut down, so be careful not to introduce too much cold water too fast. Check the compressor drain valve. It'll blow steam and water for a little while, but should begin to blow only steam after a minute or two. When it does this, shut it off and close the vent condenser vent valve down to where just a wisp of steam escapes. Now, open the feed water control valve slowly to twice the normal distillate rate. That'll be 10 gallons per minute on this 300 series, 13.6 GPM on the 400 series, and 20 GPM on the 600 series. When the sump level rises to within 3 inches of the top of the gauge glass, open the blowdown shutoff valve. Here. This will carry off the impurities left behind after distillation has taken place. When everything seems to be flowing smoothly, turn the automatic heaters to auto. One manual heater should be on. Next, turn the salinity meter on. If the distillate is pure, the meter will read 5 parts per million or less. Once it gets to this stage, the distillate can be stored, and the chemical treatment pump can be turned on. Make sure that the chemical treatment tank is filled with the proper chemicals. Wait a minute now. What's happened here? An automatic shutdown. That's what happened to you, isn't it, Sam? It can occur during the startup procedure for several different reasons. Usually, it'll be due to the recirculation water dropping in temperature. Naturally, this drop in temperature reduces the pressure in the evaporator. When the pressure drops below 0.5 inches of mercury vacuum, the unit automatically shuts down to prevent damage to the centrifugal compressor. To get it started again, turn the salinity meter off and push the reset button on the front panel. Then, start the lube oil pump, turn the heaters on, and shut the feed water off. Check the boiler water level to ensure that there's plenty, because a low water level will also trip the master control circuit. When the recirc temperature reaches 214 degrees, go through the startup procedure again. Once the unit is producing distillate, check the compressor suction pressure. If it's maintaining its 0.5 to 1.0 psig pressure, turn the automatic heater to auto and leave one manual heater on. It should continue to maintain the pressure. If it drops and the unit is equipped with 2 manual heaters, go ahead and run the unit with both manual heaters on. This might have something to do with your problem, Sam. The evaporator temperature dropped and reduced the pressure.
Well, what caused that to happen? And how do I prevent it in the future?
Well, it's usually caused by trying to introduce too much cool water into the unit too quickly. But if you've been watching it closely and you're still having a problem, then I'd say your incoming water isn't being preheated properly by the heat exchanger. And that can be traced back to the blowdown strainer basket. Look at that. That's a lot of scale in that basket. It was restricting the blowdown flow through the heat exchanger, which was limiting the exchange of heat to the feed water. That causes colder water to be entering the system and can create the problem you were having. You should clean it before you even try to start the unit up, and while the unit's operating every 8 hours by bypassing the strainer. Don't forget to put it back online after you've cleaned it. There are a couple other things to watch for while the unit is operating. Every now and then, check all flow rates to make sure that everything's running at the proper rates. If the compressor suction pressure begins to drop, turn the heaters back on manual until it comes back up to between 0.5 to 1.0 psig. You might have to readjust the automatic heater pressure switch if the pressure level won't stabilize. Check your manual for this. If the compressor discharge pressure increases and distillate production drops abnormally, it's probably because of a buildup of non-condensable gases which have accumulated in the tube bundle. This can happen if your vent valve isn't opened wide enough to allow them to escape. Just open the valve for about a minute. This will allow the non-condensable gases to escape. Then close it down to a wisp, but open just a little more than before. This should bring things back into proportion.
Okay, I think I've got it. Now that it's going, what do I do to keep it from breaking down again?
Well, the most important thing is to be sure to perform the maintenance at the specified intervals. And there'll be other problems that you run into. We'll take a minute to cover them, but first, let's go grab a quick cup of coffee.
Okay, now, where do we leave off?
From time to time, your spray nozzles inside the evaporator might get clogged. Generally because the scale or solids are getting past the sump strainer, or your nozzles might erode, like this one's done. Both cause the spray pattern to be affected, which will cause lower efficiency. Check through your inspection windows to ensure that the spray coverage is correct. If it's not, find out why and fix it. If you discover that the bronze nozzles in your unit have eroded, it'd be best to replace them with stainless steel nozzles. The bronze ones erode pretty fast. What's the problem, Sam? You got one that's clogged?
Well, I'm just replacing all the old bronze nozzles with these new stainless steel ones.
That's a good idea. You should wait until the bronze ones wear out first. You might as well get as much life out of them as you can. After you've installed the new ones, make sure that the spray pattern is correct. They should be installed so that the diamond patterns on the head of the nozzles are faced in this direction. Have you checked yours yet, Sam?
Yeah, the spray pattern's real good.
Okay, good. Here's another problem. If you see scale buildup on your tube bundle and neither acid slugging nor acid cleaning seems to clean it off, you might be experiencing a buildup of calcium sulfate scale. Take a sample of the scale from the tube bundles. Mix a strong solution of AC2, about 1 teaspoon in 8 ounces of water. Drop the sample in. If it doesn't dissolve, it's almost sure to be calcium sulfate, and you'll need to get some AC8. The information for using AC8 can be found in Bulletin 750-1036 in your Aquachem manual. It's introduced into the unit through the acid pot, just like AC2 is, but it has to be circulated at 220 degrees Fahrenheit in order to dissolve the scale properly. Be sure to read the instructions fully before you use it. It'd be a good idea to take some of the scale from the blowdown strainer and put it to the same test every now and then. If it dissolves in the concentrated AC2 solution, you probably don't have a sulfate problem. You should do this prior to acid cleaning and keep good daily logs. Your logs still need some help, so let's go over how to take these readings and what they mean so you'll be able to troubleshoot. Remember, you should take these readings every day, and you'll have to do it while the water maker is operating. The form that is to be filled out is the daily operational data sheet. All of the different gauges on the Aquachem are listed here. First, you'll need the model and serial numbers off of the nameplate on the control panel. Then the date and time of day should be filled in. Next, the total number of hours that the system is operated, off of this hour meter. This will help you in determining how many hours the system has been run. This is the suction pressure. It monitors the steam pressure in the evaporator shell at the compressor inlet. It should read between 0.5 and 1.0 psig. Ours is reading 0.9. If the pressure is too high, the evaporator scale will form more rapidly, and if it's too low, the compressor will surge, causing compressor damage. The adjustment is made at the automatic heater pressure switch. If your heater correction doesn't seem to make a difference, make sure that your feed water rate is correct, steam chest vent valve is set for just a wisp, all electric heaters are turned on and operating properly, the recirc pump flushing water is about a quarter of a turn open, the distillate and blowdown outlet temperatures are not more than 15 to 18 degrees Fahrenheit higher than the inlet temperature. This last check will tell you whether or not the heat exchanger is scaled over. Discharge pressure, the second of these three gauges, is logged in the next space. This one is reading 3.5 psig. Compressor amps and voltages should be checked once a week. Many of our operators prefer daily checks as an absolute measure of performance. These gauges are optional meters and aren't usually included on Sedco's Aquachems, so it'll be necessary to get the rig electrician to take these measurements. Only the rig electrician should take them. Voltage can be taken with a simple volt-ohm meter at the three-phase inlet at the panel main disconnect breaker. The Aquachem manual has the proper specifications for your particular unit. To check the amperage, the electrician will use a clip-on ammeter, like this one. It should be read only after the compressor has had a chance to get up to operating speed. All three phases should read within 10% of each other. Again, the proper specs can be found in your maintenance manual. These readings are entered on the logs here. High amperage readings at the compressor motor indicate a possible low voltage or unbalanced leg in the three-phase power to the compressor motor, which may cause overheating and possible motor failure. If you notice that high readings have been logged into that space, bring this to the attention of the electrician so that he can troubleshoot the problem. Next, check the recirculation temperature, located here. It should read about 214 degrees. As the temperature gets higher, it raises the pressure of the evaporator. It'll shut the unit down at 2 psig. Too low a temperature will cause the pressure to drop, and the unit will shut off at below 0.5 inches of mercury vacuum. We've already talked about the remedy for this. Feed water and distillate temperatures are next. The distillate will normally leave the heat exchanger at about 12 degrees Fahrenheit higher than the incoming feed water. And again, if it rises much above that, like 15 to 18 degrees Fahrenheit, it indicates that the heat exchanger is full of scale, and both the feed water and blowdown sides need to be cleaned. Blowdown temperature goes here. Steam chest temperature is read here. The next reading is taken off of the distillate flow meter. In checking distillate flow, read the levels from the center of the ball float. You can get a more accurate reading by measuring the flow as we described earlier. You might prefer to install a permanent drum on the distiller skid and run your diverted distillate into it. If the drum holds a known quantity, this one is 20 gallons, you can check the flow rate pretty easily. Or you could install a more accurate meter, like this one. It's easy to time and calculate gallons per hour. Feed water flow rate is logged. It should be about double the distillate reading. This is very important because if the feed water flow is less than that, the concentration of seawater in the boiling chamber of the evaporator will increase and cause a calcium sulfate scale. This leads to a treatment program using AC8. The salinity meter reading is taken next. For chemical, you simply log the chemical treatments used in the system, and the rate that has been determined is correct. Check its injection rate from time to time to ensure that it's accurate. If acid slugging and acid cleaning have taken place, log them. If not, just draw a line through them. Oil temperature for the centrifugal compressor is next and located on the oil pump piping. A temperature of above 170 degrees Fahrenheit indicates a problem with the lube oil cooler. It should be checked for obstructions. Lube oil pressure is the third gauge in this row and logged next. It should be between 15 and 20 pounds per square inch. If it's not, adjust the lube oil bypass valve. Next, log the type and weight of oil that you're using. If the oil filter has been cleaned, indicate this. Distillate pump discharge and recirc pump discharge pressure gauges are both optional readings that we usually don't order on our aquachems, but many rigs add them later. Liquid-filled, dampened gauges should be installed. They're designed to deal with the radical fluctuations of the discharge and recirc pumps. The readings taken off of these gauges tell whether or not the distillate and recirculation pumps are developing adequate discharge pressures to properly circulate the fluids they're pumping. The recirculation gauge is tapped off of the recirc pump at the output. Simply screw a fitting into the pump case. Do the same for the distillate pump. Lower than normal pressure levels tell you that the pump has excessive wear, plugging of the pump suction with debris, or a possible reverse rotation. Check for these problems. Spray nozzle pressure is read from this gauge and will run between 5 and 9 psig. This one's reading 9. A low pressure will cause narrowing of the spray nozzle pattern, which results in reduced distillate output and rapid scale formation. Pressure above 9 psig results in a widening of the spray pattern, causing water to be sprayed on the walls of the unit rather than on the bundle. This causes a loss of distillate production and a more rapid buildup of scaling. And finally, production total in gallons and average gallons per hour. Be sure you know what these are supposed to be reading. As you already know, distillate flow will decrease as scale develops on the tube bundle. When distillate output drops to 80% of its rated capacity, the evaporator should be acid cleaned. Feed water rate has to be kept at twice the distillate capacity to prevent excessive concentrations of calcium sulfate scale from developing in the evaporator tubes. If these concentrations get too high, calcium and magnesium sulfate will form on the heating tube bundles, causing a need for AC8 treatment. Again, these records are important. Don't slough them off, because this is how you determine your problems before they shut your unit down. Now, there are also a couple of do's and don'ts that you'll want to pay particular attention to in shutting the unit down. The feed water chemical treatment pump should be turned off at least 2 minutes before the unit is shut down. This is to flush the chemicals out so that a concentration doesn't build up in the sump and heat exchanger. Next, turn the salinity meter off and divert the distillate to waste. Throttle the distillate shutoff valve to build a distillate level in the steam chest up to about half full in the observation window. Then shut the valve off completely. This step will guarantee that enough distillate will be trapped in the unit to facilitate proper flow of makeup water to the boiler for next time. Next, turn the centrifugal compressor off, the pump motors off, and close the feed water shutoff valve. Open the vent condenser valve and close the desuperheated water valve. Then, turn the heaters and lube oil pump off, and the unit is ready to be fired up for next time. Okay, I know that sounds like a lot to keep up with. Well, wait a minute. Wait a minute, Sam. Come on back. I want to show you something. We've got this checklist in the workbook. It's easy to follow, and it's a step-by-step procedure of everything that we've covered. You can use it the first few times until it gets to be second nature. Briefly, here's what it covers. How to keep your daily output logs. Remember, when output falls below the blue line, acid slug and begin a new column. When it falls below the double red line, acid clean and begin a new chart. If everything is operating properly, your output levels will follow the levels on this chart. If they don't, there could be something wrong. And you should check your daily operational data sheet. It should be logged in daily too, because this is the best means you have of isolating problems. One way of ensuring your unit's proper operation is by maintaining your maintenance schedule. Perform the needed maintenance at the recommended intervals, and you'll save yourself a lot of trouble. During startup procedures, make sure everything is done in the proper sequence. This sequence is listed in both the maintenance manual and your AquaChem workbook. When you have a problem with your unit, look for the source of the problem, not just the result. A buildup of calcium sulfate scale, for example, is caused by a high concentration of impurities in the sump. AC8 treatment will usually get rid of the buildup, but you should determine why the buildup occurred to begin with. Too low of a feed water level, restricted blowdown, whatever. There's a handy troubleshooting guide in both the maintenance manual and the workbook. Use it. If your problems continue, contact the experts in Dallas for help. Be familiar with the types and uses of the different chemicals you use, whether they're Aquachem chemicals or some other brand. Read the brochures and know what the proper quantities and uses are. And know the proper procedure for shutting your unit down. There's a procedure checklist in the manual and workbook. Well, Sam, what do you think? Did you learn anything?
Well, that'll help a lot, but I really think some of these things need a little more detail. Like the centrifugal compressor here.
Well, we'll pick that up in an in-depth look at the centrifugal compressor and other things in the next part. Here, take a look at it.
Okay, thanks a lot. I'll do that. By the way, if I keep good records and this thing keeps working okay, how about a little raise?